All right, welcome. Hello, everyone. I'm James Ward. I'm a developer evangelist at Heroku. Okay, how many people here have used Play Framework before? A couple people? Awesome. Okay, great. So hopefully this will be a good introduction for the rest of you to Play Framework and how it works and that stuff. So feel free to stop me and ask questions at any time. Also, if you're in the back, you may not be able to see my code examples because the font in IntelliJ is kind of small. If you can't see it and you want me to increase the font, just raise your hand and tell me, like, hey, increase the font for me. So, okay, let's get started. So I want to start talking about some of the trends that we're kind of seeing happen with web applications right now. We're seeing this big change in how we build web applications. Some people are calling it modern web apps. I don't think we've really totally decided on a term yet, but there's three primary characteristics of modern web apps and the changes that are happening. So first, the Stateless Web Tier. That's really being driven by a couple of different things we'll talk about later. But one is continuous delivery, and then the other one is scalability in the cloud. And then client-server web apps and mobile apps. This is where we're going to spend a lot of time talking about today, is this new architecture for how we build modern applications using web technologies. It's really the client-server architecture just redone on top of web technologies. So we're going to spend a lot of time there. And then we'll spend a little bit of time talking about real-time. I think real-time is becoming a really important component of this. And Play Framework 2 now has some really great support for doing this as well. So we'll spend some time there. So first, like, why? Why are we changing our architecture for how we build web applications? Do we really need this? And I think there's really three primary drivers that are pushing us in this direction of modern web apps. The first one is performance. We have been constantly running into performance issues with the traditional web application architecture, both in a number of different areas. One, in how we utilize bandwidth, another in how we use compute cycles between the client machine and the server machine. And so I really think that in a lot of ways this modern architecture is enabling us to build more performant applications, both in the browser and in mobile clients using things like PhoneGap and that sort of thing. And then the next one is faster development iterations. So we typically, as Java developers like me, when we build web applications today, we're working in code that is for the client side and the server side, all in the same kind of code base and same area. And what this does is it makes it so that our iterations actually slow down because the changes that we're making end up affecting a large kind of wide swath of our application. So what we're doing when we move to this client-server architecture is actually splitting out the client-side development cycle from the server-side development cycle. And this is becoming a pretty big shift for a lot of Java web application or any web application developers. I think that in the future we'll actually see a pretty significant split. Whereas a lot of us that have built web applications, we've written the back-end code, we've written the HTML, we may have written some JavaScript. What I think will happen in the future with this new architecture is that you'll be either a front-end developer writing JavaScript and HTML and CSS, maybe a little bit of back-end code, or you'll be on the other side. You'll be a back-end engineer, you'll be exposing RESTful services, you'll be figuring out how to talk to MongoDB and other NoSQL and big data systems. But I think that this split is coming. You may have to decide, unless you're in a small organization, you may have to decide in the future which kind of way you want to go. Do you want to write JavaScript in the browser, or do you want to write the server-side services? Obviously, if you're in a small organization, you probably will be able to do both. But I think as we move further down this direction of client-server, there will be a pretty distinct role split there. So and then the last one here, why, is that we're able to now reuse the services that we're building on the server side for mobile clients, web clients, potentially desktop clients or other clients. So this reusability of services is huge, really being driven by the mobile space now. And then tools like PhoneGap allow us to even reuse a lot of our client-side code, our JavaScript code and CSS and all that kind of HTML, all that stuff as well. So then let's talk about the Stateless Web Tier. So the things that are really great about the Stateless Web Tier is first, server affinity. When a lot of us do typical web application development, we have a lot of state in the server for the user. That state, in this case, like session state, is there so that if a user makes a request and then makes another request, we have some state information held between those requests, right? If it's multi-page, or a lot of the web frameworks just use this state as part of the component model. But the problem with this is that it doesn't provide us a way to do simple upgrades and simple scalability. When we go to a stateless model where we get server affinity, meaning that a server can drop out at any time, a new server can come up at any time, and requests can be routed to any server, doesn't matter, then it allows us to much more easily upgrade our application and scale it. And so obviously state has to be somewhere, right? Like we have state in our applications. Very, very few applications out there are purely stateless services. So we have state. But what's beginning to happen is we're moving the UI state actually out to the client. So that means that it's held in memory on the client side through JavaScript. Or potentially if we have state on the server side that we need on the server side because we're using a traditional web framework, we can put that into an external system that can be very fast, like Memcache or MongoDB or Redis, and move that state information out of the web tier layer into some external system so that we still get the server affinity in our web tier. Okay? And then continuous delivery, the next big part of this, as I mentioned, that's really just assisted by the fact that you hear these horror stories where people say, like, all right, I want to do an upgrade of my system. And to do that, I actually have to wait until I'm going to bring up the new system, and then I'm going to wait until all of the users that are on the old system have actually, their sessions have expired. So the load balancer is, sending people, if they've got a session, to this old system, and then as soon as all those sessions are gone, then they can finally shut down that old system and finally, just switch completely over to the new system. That is not continuous delivery. That is a huge pain for doing upgrades. There's a lot of weight to doing upgrades when we work in a system like that. So the stateless web tier is really helping us to move to a place where we can just do upgrades and we're not going to have to worry about losing user sessions, those sorts of things. So then the last one is that when we do session state in an application, a lot of times we'll break the browser functions with back, forward, reload, and we don't want to do that. One of the Play Framework guys has this great quote. He says, if your web framework fights with the HTTP protocol, it's the HTTP protocol that wins, not the web framework. So don't pick a fight with the HTTP protocol. The HTTP protocol is inherently stateless, and so web framework should embrace that and not try to fight that. We'll see kind of examples of how that works in play in a little bit. Okay, so the next one, client-server, web, and mobile apps. So this is really the big change that I think is affecting a lot of us right now as we think about our next generation of apps. We're moving to RESTful services, primarily JSON for the serialization of that data. RESTful, for those of you that may not be familiar with it, it's just this idea that I have these stateless URL patterns that map to being able to get data, update data, and we're using the HTTP verbs as the way to the HTTP verbs and URL patterns or paths to describe the action that I want the server to take. So we'll see examples of this in just a few minutes. The thing that I'm going to talk about at the end, which I think is kind of new and exciting, is once we move to this architecture where we've got this separation between our RESTful services and our client side that's written in JavaScript and CSS and HTML, a lot of my client side now becomes static assets, static content. And what's great about that is now I can take those static assets, that content, and instead of serving it from my application server, I can instead serve it from a content delivery network. I can actually take the whole client side of my application and move it out of my application server and onto a CDN so that it's edge cached around the world and very low latency, very fast to download that static content. It caches really well. So I'll show some examples and talk about that towards the end. Okay, now transparent real-time. If anybody here has used Trello, Trello is an awesome app for doing project management type of stuff, product management. What's so compelling about it to me is that you're in this app, and if somebody else is in it at the same time, it's always up to date, right? If they change something, you see it instantly on your screen. If you change something, they see it instantly on their screen. I know there's lots of other tools out there that do that. Google Docs. The thing that really was compelling to me about Trello is that it's this real-time collaboration in the context of data. And that's, of course, enabled through real-time and comment and these sorts of things we'll get into more later. But this is really beginning to change how we think about web applications. We used to put a lot of work into thinking about the fact that our data was always stale on the client, and how do we deal with the stale data, and what happens if that data, the stale data gets sent to the server. Do we have to detect, like, were they using a stale version of the data instead of the newest version of the data? Essentially, our data was always out of sync on the client, right? And so we had to do a lot of work to account for this. It was never a good user experience to have the client-side data out of sync. So what's happening now, Trello is a great example of this, is that the data is now kept in sync in real time with the server data. That's I think the best place where I see real time being used. Of course, it's being used for things like notifications. That's obvious, but I think we're still kind of in the early days of some of this. Like, how do we address scalability, and are WebSockets going to save us once they're readily available through everyone's browsers? So I think there's still some open questions about how we really get here, but I think it's pretty clear that this is a trend that our applications, the UIs, are becoming much more in sync in real time with the backend data. Okay. So I wanted to start with those trends just to kind of get us moving and thinking about why Play Framework really matters, why it's interesting to us. I think it fits really well with all those trends, and I hope you'll see that in a few minutes. But let's talk a little bit about HTML5. This is the definition of HTML5 on Wikipedia. To me, the definition is much more simple. It's that the browser is now an application platform. That's really what HTML5 means to me. I know that HTML5 is a set of specifications, and there's actual technical definitions of what HTML5 is. I think when most people are talking about HTML5, they're really talking about using the browser or web technologies as an application platform. That for the first time, we're really being empowered to do that, rather than just using the browser as this dumb rendering terminal, essentially. So HTML5, there's a number of new tags in HTML5, video tag, and section, and article, and header, and nav. Most of us probably aren't going to be using the new tags or even a lot of the new APIs in HTML5 for a while. And the reason for that is that this stuff is not ubiquitous yet, so it's great for demos, but and it's actually getting more ubiquitous on the mobile front. So if you're building mobile apps, you may be using some of the new APIs. But if you're building standard browser apps, you're probably not going to be taking advantage of most of the new stuff in HTML5. So don't let that deter you. People will be like, oh, what you're building, you're just using jQuery and Twitter Bootstrap. That's not really HTML5. Technically, that's true, but what you are building is a modern web application. And I think that's why people have kind of backed off of using HTML5, and we're kind of switching now to describing this more in terms of modern web application instead of the actual specifications of HTML5. I think one of the real big things that's driving this change in modern web applications is the fact that the browsers have gotten a whole lot better at executing JavaScript, and that's really enabling us to move the processing of the UI from the server side to the client side. So I think that's really the key here for what's happening. But nowhere in the HTML5 spec does it say that the JavaScript engines must be this fast, right? So it's not an HTML5 thing. It's just that browser modernization under kind of the banner of HTML5 is what's really driving this to move to this modern web architecture. Okay, so HTML5 really for most of our uses, HTML5 really just means modern web apps. Okay, so the interesting thing about what's happening is that we kind of are reinventing a lot of things in the browser right now in the modern web application architectures. So jQuery, it's of course been around for a long time, but that's really become like the standard API that we build against, that many of these modern web applications build against, is not building against the browser APIs, but building against jQuery and then potentially other libraries as well. So if you are going to be doing modern web application development, you probably will be using jQuery. Twitter Bootstrap, it's a great way to make your web applications look great and be sexy. For me as a developer, I'm not real good at UIs, so Bootstrap really helps me to apply a decent looking UI with very little work. So that's a great tool that's evolving quickly. CoffeeScript you may have heard of. I think there's a CoffeeScript session going on right now. It's just cleaning up JavaScript. It, of course, generates into JavaScript, but it cleans up a lot of the nastiness of the JavaScript language. So, so you may or may not be using CoffeeScript. You'll actually see some CoffeeScript in a few minutes. So we'll get to that. One of the most exciting things that's happening for me right now in this space is asset compilers. So as we move this client side of our application actually out to the client with JavaScript and HTML and CSS, we need some way to integrate what we're doing on that side of the development spectrum into our development cycle, into our development flow. And so the asset compilers, what they do is they help us to do that. So the Play2 asset compiler, and I think the Rails one does this as well, it'll run our JavaScript through the Google Closure syntax checker for JavaScript, so that we'll actually see JavaScript essentially compile errors in our development cycle, rather than waiting until we find them, through some execution path in our code. And then it'll do the same thing for CoffeeScript and for Less. So really integrating these new technologies into our development cycle and making it an end-to-end spectrum development cycle is really a huge thing that's happening here. And then MVC framework. So as we're moving our client side out to the client, we are recreating a lot of the same things that we had on the server side, like MVC frameworks and templating systems. We're recreating that for client side. So we're recreating these in JavaScript. So there's a number of MVC frameworks out there. There's tons of them. A number of client-side templating languages out there. I don't have a particular preference yet. I think that these are evolving very quickly. So I don't have a preference on which one to use. My suggestion would be try them. Give them a try. Read some blog posts there's a great one by LinkedIn. Someone did a great one on the different, writing to-do list applications in these different ones. So try them out and see which one connects with you. It could be Angular because it's kind of I believe that one's like JSP-ish, or it could be Backbone because it feels good with jQuery. So give them a try, see what connects best for you. Okay, now let's talk about Play Framework. Let's get into the fun part. So Play Framework, here's their definition on their website. Blah, 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 blah. Here's what really matters. Play Framework, it's lightweight, stateless, it's web-friendly, so it doesn't fight with HTTP, and it's for highly scalable applications. So that's really the core of what Play Framework is all about. So my top 10 features: simple, URL routing, parameter binding, class reloading. I'm going to go through, you're going to see all these in a few minutes, so feel free to read them, but you'll actually see them in action in a minute. I do want to talk a little bit about the differences between Play 1 and Play 2. Play 2 was just released a few weeks ago, and so it's pretty new. It was actually rewritten in Scala, so a lot of Play 2 is essentially new. It's a lot of the same concepts, but they rebuild a lot of the internals of Play 2. So it's kind of like a 1.0 product. It's still got some rough edges that they're working out, but I do want to highlight some of the differences between Play 1 and Play 2. So one of the big drivers for Play 2 was that Play 1 had a lot of magic in it. They were doing a lot of bytecode modification, a lot of kind of tricky compiler stuff to make things work. And that was really cool, really sexy. It was just wow, I can't believe that worked. It was magical. But the problem with that was that when the magic didn't work, you are just why didn't it work, right? It became really hard to figure out what the problem was. So what they've done in Play 2 is said, all right, we're going to try to actually do away with all the magic. No more magic in Play 2. Let's not make any crazy bytecode modification that's doing weird things. So Play 2, they're trying to be more I guess real in the sense of not exposing what's going on to you. So that's a good thing. The next thing that I think is probably the biggest thing here is that Play 2 is now the official web framework of the TypeSafe stack. So TypeSafe is the company behind Scala and Akka, and Play 2 is now their web framework. So I think this is a huge thing for Play Framework to be recognized as and supported as part of the type-safe stack. So I think that's a really good thing for them. Play 1 used Hibernate for persistence, Hibernate and JPA. Play 2 now has different persistence options whether you're writing your application in Java or in Scala. If you're writing in Java, then eBean is now the default persistence provider. And if you're writing in Scala, then anorm is the default persistence provider. So you can swap that out. You can change it to whatever you want. You can use, this is for relational databases. You can, of course, put in MongoDB very easily and those sorts of things as well. But this is the default persistence providers now in Play 2. In Play 2, they've integrated Akka and async into the framework. We'll talk more about this when we talk about comment and WebSockets in real time. But this makes really lightweight, really efficient ways to do long polling, comment-style long polling, to do real time through WebSockets, that sort of stuff. So it's pretty sexy. For templating, they have server-side templating in Play. I haven't used that very heavily because I'm going to this client-server architecture and doing more on the client side. But if you do want to do server-side templating in Play, it used to be that in Play 1, Groovy was the templating language for Java in Play 1, and Scala was the templating language for Scala in Play 1. Now in Play 2, Scala is the default templating language for both Java and Scala. So if you're building Java controllers in Play 2, your default templating language is now Scala. The templating language in Play 2 is pluggable, so you can swap out the templating language that you use. You could use, there's even now a Groovy way to do Groovy templates in Play 2. So if you want to do the Groovy templates, you can do that. If you want to do like Scalate templates, you can do that. Matt Rabel did a post on that. And then the asset compiler, I talked about that. You'll see that in a couple minutes. One of the other cool things that they did was Play 1's command line interface, when you type a play command and how they interpret that command, and if you want to put in your own kind of extensions to the play command, that was all done through Python in Play 1. So it's kind of nasty to have part of the Play system relying on Python. That meant you had to have Python on your system. So there were some challenges there. So what they've done is they've actually moved to SBT to run their command line. SBT is the Scala build tool. So really the Play command line now is essentially a plugin for SBT. So it's a pretty nice architecture that's all based on Java now. And then they've moved from Ivy for doing their dependency management to SBT, but SBT uses Ivy under the cover, so it still has all the nastiness associated with Ivy, unfortunately. And then for doing configuration, they've moved from a custom configuration system in Play 1 to using the type-safe configuration system. That's the one by TypeSafe, the company, for how they handle configuration. It's a great configuration system written by Havoc Pennington, who's at TypeSafe now. Havoc is one of my heroes. He wrote the Metacity window manager for Linux, and he works for TypeSafe now. So it's a cool configuration system, works really well. Okay, so enough talking. Let's see some code. Any questions before I dive into code? Just went through a lot of stuff. I'll make sure that everyone's still with me. Ready for code? Okay, cool. Okay, so I'm going to start totally from scratch. I'm going to write code live. Feel free to point out if I mistype something. This is pair programming. We're going to do this together. I'm going to build a simple Play 2 app with Java, and then I'll show you a Play 2 app with Scala, and let's do it. Okay, so let's go create a new app. So all that I've done to set this up is download Play 2. So just go to playframework.org, download their zip file, and extract their zip file. And then optionally, if you want to, you can add the play command to your path, which is what I've done. So I'm going to say play new and create a new app called foobar. So, and then I'm going to say, let's use Java. And so there we go. It's created my app. Let's go into foobar. We'll see that there's a few files in here. We'll explore those in a minute. But before I go any further, I'm going to generate the idea files. I use IntelliJ for my development. So I'm going to just run play idea. And this will generate the module to open this project up in IntelliJ. So that'll take a second there. It, of course, has a way to generate the Eclipse files. I don't know if they still have NetBeans support or not, but There we go. Okay, so I've got my IntelliJ files. Before I go and open it up in IntelliJ, let me just run this application. So I'm just going to type play run. So play comes with its own HTTP server. It uses the Netty server, which is just an awesome, fabulous HTTP server. It's based on Java NIO. It's really high performance, which works well. Because it's based on NIO, they can do the cool stuff with Akka, where if you've got an HTTP request coming in and you have that an actor that goes off and does some work, they can actually take that HTTP request and deallocate the thread associated with that request, go give it to someone else to handle their HTTP request, and then as soon as your actor comes back and says, all right, I'm ready, then they bring the thread back, send the response back. So it's a very efficient way to manage these connections in the system. So Netty, it's awesome. It's built by the JBoss guys, and a lot of the next generation Scala web frameworks are building on top of Netty because it supports the async and supports high performance and that kind of stuff really well. Okay, so we're up and running. Let's go check it out in the browser. Let's go to localhost 9000. So this is the default page in Play Framework. So this is a great way to get started. Just start up the Play server in a new app, and then you'll get documentation and stuff that'll walk you through how Play works and how to do it. So that's great, but let's go into IntelliJ and create a new project. For some reason, they don't create the project file for IDEA, so we do need to create this. So let's go find the foobar project, and I'm not going to create a module, I'm going to import it. So then we go import existing module, and there's my IML. Okay, so now this is my Play 2 app here in IntelliJ. So let me walk you through the different pieces of this app and how it works. So first, let's check out in here this conf directory, and I've got a routes file. So the routes file is how we map HTTP requests to the actual controller that's going to have the code to handle that request. So in this case, there's a get handler for requests to the /URL pattern, and then it's going to call controllers.application.index, so the index method on my application controller. We can do pretty complex patterns in the URL, so we can do RESTful style stuff there and pass those parameters into the controller as well. This is a great way to define the mapping between request verbs, request paths, and the code to execute. So let's go take a look at that controller. So if we open that up, this is our Java controller. So this is an application, class application. So in this case, application.java. It extends the controller class. And then there's a static method that returns a result named index. So that's actually what's going to get called when we make this request to /. So the cool thing here that they do is they say, all right, we're going to use a static method for this. The reason for that is that they're really trying to get you to think about HTTP as a stateless protocol. So instead of having a controller here that can have state, they're really trying to get you to think of this as, in the HTTP protocol, I make a request and it returns a response. And there is no correlation between that request and the next one. So that's why this is static, is they really want you to think in terms of the HTTP protocol and how it actually functions. Some people, ask questions about, oh, it's static, how do I test this? They have really good testing support for how you can wrap functional tests around these. But you probably wouldn't want to put a lot of logic in here. You'd want to move that out into some other file so that you could test that independently of your web actions, essentially. Okay, so then this particular method, what it does is it returns OK, so that's status 200. So again, they're not trying to hide the HTTP protocol from you. When you say you return OK, you are returning a status code 200, right? And then what they're doing is they're calling a template here, index.render, and passing it a string. And so what happens with that is if we look in, so my app directory is my main source directory for this project. And then I have a views package in here. And this is where my views are. So this is my index.scala.html file. What Play does is they actually compile this file down into an actual Scala class. And that Scala class is now available via this index. If we look in my imports, what we'll see is I'm importing views.html.star. And that's where index is coming from. And then I'm calling the render method on this object. So this is just, play has gone from the Scala HTML file to a compiled class. And that's what's actually happening here. So there's some type safety with my templates and how I use them. So we can also see in here in this template that the first line is the parameters that this template takes. So I'm calling this template with a string parameter. So sure enough, we'll see that my parameter that this template takes is a string. And then the next thing we see is that we're calling @main, and main is just another template. So just like before, we can call these templates and pass them parameters. So this one takes 2 arguments here. Let me increase that. So 2 arguments for the main template. There's the string title and there's the HTML content. If we look back here, we'll see that here's the first parameter, that string, and then here's the second parameter is a block that's going to contain some HTML. So that's how I'm actually reusing templates and extending templates essentially. So now inside of this main part, actually let's go back to the main template here. So we'll see that where that content that gets passed in as a parameter, that gets put into the body part of this page. Okay? So what we're putting into the body of this page is this play2 welcome message with the string that got passed into the template, and we're telling it that the style is Java. There's 2 different styles, Java and Scala, so it just will change the documentation that you see when you start up play. Okay, so we've got that. Let's start making some changes here. So let's go first to our let's go in here. I'm going to do message.to uppercase. So let's go refresh the browser. So I just changed the title to uppercase, so it's going to recompile, and now we see that title now is changed to uppercase. So this is the development experience in play. I've got my server running, and I'm just going to start changing templates and changing routes, changing configuration, changing Java classes or Scala classes, and I just hit reload in my browser, and it's going to do all the recompilation and everything for me. So it makes for this really quick iterations in the development process. So that was changing a template. Let's go actually now change the message that this Java class is passing in here. Let's go change it to hello Philly and save that. And again, just hit refresh in the browser. It'll now recompile that Java class, and now we see the change there. So this is so much better than the typical development process in Java Web Frameworks, where you save your files, and then you've got to recompile, and you've got to rebuild a war file and redeploy your war file and possibly restart Tomcat. It doesn't always have to be that bad, obviously, but the fact that in Play Framework, all I ever do is start up the server, write code, and hit reload in my browser. It makes for this really rapid, iterative development cycle. And that's I think, my favorite thing about Play Framework is just how quickly I can iterate. And when we get into the asset compiler stuff, this isn't just for back-end code. This is for my front-end JavaScript and CoffeeScript and less code as well. So it's really that end-to-end development spectrum. Okay, so that's a simple change. Let's do something a little more exciting in this app. Let's add in a model, talk to a database. So to do that, let's go create a new package here called models. And then I'm going to create a new Java class, oops, not a new file, new Java class called bar. So I'm going to store a list of my favorite bars here in this app. So I'm going to extend the model class in Play Framework. So the model class, it's basically a wrapper around eBean that makes it easy to like do finders and that sort of thing. So I'm also going to just annotate this class with the standard JavaX persistence entity. So nothing too special there. And then I'm going to also use the standard @ID for the primary key. And I'm going to do a public string ID. I'm using public properties here. You can use getters and setters if you want. My getters and setters usually don't do anything special, so I just prefer public properties. But up to you how you want to do that. Then let's add in the name of the bar. So I'll do another public string. there. So very exciting. There's my model object. Now let's go, and we actually have to do a little bit of configuration in Play to tell it about the data source and to tell eBean where to find the entities. So going here to the application.conf, and I'm going to set up to use a just in-memory H2 database. And I'm also going to tell eBean to look in the models.star package there for models. So now if I go back and hit refresh, now it's just going to read that configuration. And eBean's going to notice, hey, you know, we don't do this automatic, or we can, but by default, we don't do automatic schema changes for you. We have this concept in Play of doing database evolutions, which I believe Rails has as well. And so what we're doing is saying we're not going to explicitly start changing your schema unless you tell us that you want to do that. You're going to have to say, I want to change my schema. This only works in development mode, essentially. So usually in production, you would not, you know, have your users potentially see a screen that's telling them to apply the evolution. Right, that would be a bad thing. You don't want your users, you know, seeing your schema and stuff. So usually in production, you turn this off, and then you'll probably manually do your evolutions. But let's apply this script, so that will create my bar table in the primary key sequence. So that's good. That's created in the database. One thing that got created here was eBean creates this evolution script for me. So this was automatically created by eBean. It has my create table, it has my sequence, and what we do for schema evolutions is we have ups, meaning if we're going up to this version, and downs if we're going down from this version. So in this case, down drops the table, drops the sequence. And if I wanted to create the next version of my schema, I would create 2.SQL. And 2.SQL would then be applied after 1.SQL. So this allows me to play into this continuous delivery where I can very easily roll out updates to my schema and have ways to downgrade if I need to. So Play has that built in. The way that they've structured the actual directories is in my conf directory, have evolutions, and then default is the name of my data source. So this is a new feature in Play 2. Play 1, you could only have one data source, which was kind of unfortunate. Now we can have multiple data sources, and we just refer to those by name. So you'll see here in my config, I've got db.default here. So that's configuring the default. But if I needed another database, another data source, I could configure that as well. Okay, so that's the default here matches the default, which is the name of my data source. Okay. Okay, so I've got my bar. It's all created in the database. So let's create a way to add new bars into the database. So we'll start with going into the routes file, and I'm going to add a new route for a post request to /add bar, and I'm going to call controllers.application.add bar. Now let's go into application and let's go add that method. So I'm going to create a new public static. It's going to return a result, and it's going to be called add bar. So now what I need to do is get my form parameters that are going to be submitted out of the request and turn them into my bar value object. So Play in Java has a nice way to do this kind of auto-magically. So I guess there's a little bit of magic still left in Play 2. If you do Play 2 with Scala, you have to explicitly define your mappings between the request parameters and your case classes in Scala. So we'll see an example of that in a few minutes. But to do that, what I do is I'm going to create a new form object here. Let's import the right one. And this is going to be a form of bar. Let's import our bar. And then what I'm going to do is I'm going to create a new form. And it's going to take a bar.class, and then I'm going to bind it from the request. So I'm essentially binding the request parameters into this form. And then to get my bar out, I'm going to do bar, I'm going to do form.get, and that will get my bar that's been populated with the values from the request. Okay, so pretty easy to get the mappings there, the request parameters. So because my bar extended model, it now has a save method on it. So now I can just call bar.save. That'll save the bar object. So now last thing, I've got my bar saved. I'm just going to redirect back to the index page very simply in this case. So to do that, let me increase my font a little bit more. So to do a redirect, I'm going to return a redirect, and Play has a reverse routing table. So everything that I define in my routes file gets compiled into a forward routing table and a reverse routing table, so that I can determine my URLs in a type-safe way for like the index URL. So to do that, I say routes.application.index, and that will return the correct URL pattern that's been determined by looking at my routes file, compiling it into the reverse routing. Okay, so that's how I do a redirect back to the index page. Okay, so that looks good. Let's go now into the HTML page, and I'm going to take out the welcome message and do something else here. So I'm going to just create a simple form. You can use some Scala APIs that they've provided to create forms for you. I'm just going to do the basic form. And in this case, I'm not doing the new sexy modern web app style. I'll show that in a minute. I'm going to just do standard form here. So no JavaScript required. So let's create a new form, and I'm going to have the action be /add bar, and the method be post. And now this is going to take a parameter here, name equals name, and that name is the name of the field on my bar object. So that's how it knows how to do the automatic parameter binding from the form, is based on the name of the request parameter. Okay? And then let's do another input here, and this one's going to be type submit, my very complex form there. Okay, let's go and hit refresh, and we should see in a second my nice form for adding new bars. Okay, there we go. Let's go add in a new bar. And it looks like it worked. It redirected back to the index page. I didn't get any errors, so I think that it added a bar. And so we'll create a way to get our bars in a second. Let's go jump in and do that. So first, in our routes file, I want a way to now get these bars out of the system, but I want to get them as JSON, and then I'm going to use jQuery to get the JSON and render the bars on the page, all client side rather than returning HTML. So I'm going to do a get request handler for /list bars, and this is going to call controllers.application.list bars, and let's go add that method. So now I'm going to do a public static result list bars. And now I need to fetch my bars. And I'm just going to get all of them. Very simple here. So the eBean stuff in Play has a nice way to do finder methods. So I'm going to first just create my list of bar. Let's import list there. So I'm going to get my list of bars. And I'm going to do a new model.finder, and this takes, nope, wrong, IntelliJ, trying to be smart. Okay, model.finder, this takes the primary key type, so string.class, and then the actual value object type, so bar.class. Okay? And then I'm just going to call .all. So I'm going to get my finder, which takes those two parameters, the primary key type and the value object type, and then call .all, and that'll get my list of bars. Now I'm going to return this list of bars as serialized JSON. So to do that, Play makes it very easy to use JSON. So let's return a OK. We're going to say OK, and then I'm going to say to JSON. And I'm going to give it bars there. And then I just got to import to JSON, go import the static method there for to JSON. Okay, so that's going to take my list of bars and return them as serialized JSON. Very simple. So let's try it out. Let's go to the browser and just go to /list bars. So /list bars. After it compiles, we should see my JSON. There it is. So there's my JSON array of my bar that was in the database. Okay, very simple. We've got the serialized JSON. So that's great. We've got some JSON. But now let's take this a step further and do this kind of the new style modern way and have jQuery fetch this JSON and then render it on the page. And I'm going to use CoffeeScript. You could, of course, use JavaScript, but I want to show you the asset compiler stuff. So to do that, let's go to our index page here, And now I'm going to insert in here a new UL that's going to hold my bars. So this is going to be just an unordered list of my bars. And then I'm also going to add into here a script, type JavaScript, and the source, we'll fill that in a second. So before we fill that in, let's go actually write the actual coffee script that will become JavaScript that I'll use here. So to do the compiled assets in Play, I put those in my source directory rather than putting them in the public directory. So the public directory is really just for these static assets. You'll see jQuery is in there, my CSS is there. So I can put just plain old static assets here in my public directory. But if I want things to run through the asset compiler, I put them in my source directory, and I create a new package here called assets.javascripts for JavaScripts. If I was compiling less, it would be assets.stylesheets. Okay. So now let's create my new index.coffee. So here's index.coffee. I'm going to write the coffee script now to make the request. So first thing, I want jQuery to, when the page is loaded, I'm going to do a callback function. So that's the way we do that in jQuery and CoffeeScript is say, when we're ready, call this function. And now I'm going to do a get request to /list bars. And then this takes a callback function that gets called when we get the async callback from getting our data back. So that function takes a parameter data, and then here's the body of that function. So data will actually be our now deserialized JSON. So this will actually be JavaScript objects at this point. jQuery will automatically do that deserialization for us. Okay. Now let's do each. I'm going to iterate through each of the bars. So I'm going to pass it data. And then the second parameter of this function is another function that I'm going to call for each of the bars. So this takes two parameters. First the index number, and then the actual bar, and then my function body. So now what I want to do is I want to find that bar's UL in the page. So with jQuery, I'm just going to look for that by the ID. So I'm going to say, find the bars object on the page, the ID, the one with the ID of bars, and then append onto that a new list item. This is kind of the not so good demo way to do this, but I'm just going to append onto this a new string with my list item, and then back. Okay, so that's good. That's my whole coffee script. That's my client side that's going to do the get and fetch the data and render it. Does that all look right? Oh, bigger font. Sorry. Thank you. Thank you. Okay. That better? Okay. Okay. So back here, I need to now have the script load from the compiled version of the script. I don't want to load the coffee script source in my page. I want to load the JavaScript version of that, the one that's been compiled by Play. So to do that, if I make a request for /assets/javascripts /index, I can either do index.js, and Play will know that when I make this request for index.js to go find the asset that could be index.js because I'm using JavaScript, or could be index.coffee. So it knows to look for either of those. I don't know what order it looks, but or I can also do index.min.js, and it will automatically run my JavaScript or CoffeeScript through a minifier to minify it automatically as well. So let's just save that, come back to the browser and hit reload. And hopefully, okay, now we see our foo. So let's go add another one to make sure it works. So when this page is loading, when it's loaded, jQuery makes an AJAX request to get the JSON from the server, pulls it in, and then goes through each of the bar objects and renders them inside of the UL. Make sense? Cool. Question?
Does the asset compiler put a hash on that for the JavaScript resource, kind of like the Rails assets that one does?
I don't believe so. Is that something we can see through Firebug? Let's go take a look at here. So this is the minified CoffeeScript there. It doesn't look like it.
I'm saying, yeah, the JavaScript source hash.
Let's go see. Not in this case. So that's just that one. So is that for like long-lived HTTP, like future, like long-lived? So it doesn't, the browser doesn't reload that, or?
Yeah, plus like they could change your little version control around your files.
Okay.
So if you could change your JavaScript now, the browser will, instead of getting the cache version, they'll need to get a new version of that.
Okay. They do support 304 handling for this, so you'll see in this request that it did correctly get the 304 not modified for that. So I guess there's maybe the first level of doing that, but there's another level that we can do with this to do even better, more aggressive caching like I guess Rails does. So it doesn't look like they've implemented that part yet. Yeah?
Where was your reference to jQuery?
Oh yeah, good question. So jQuery, in the main template, so this is my main template that my index page is essentially extending. So this is where jQuery comes in. So you'll see that they're specifying the route there. I took the shortcut. I knew the URL, so I didn't use the routing table to look up the route to my JavaScript or to my CoffeeScript, but they're doing that and then pulling in jQuery. So that's probably the more correct way to do that. But yeah, so it was just part of like the base page that I was extending. Any other questions? Yeah.
So if you did a typo in your routes file, it was list foods instead of list bars, when would that get caught? When would that show?
Great question. Let's try it. So this is a great thing about play. So you're saying like just make a typo here and hit reload. So this is the thing I love about play is that everything is being type checked. Everything is being static, checking this stuff. So the routes file saying, hey, there is no method on there. So it's when I hit refresh in the browser, that's when play triggers everything to be essentially recompiled or rechecked. The routes file does get compiled, so it actually is going through a compile step there. Likewise, let's go back to my CoffeeScript, and if I make some weird error in my CoffeeScript, I will also see, as I mentioned before, the error in my CoffeeScript. So I'm getting like line number that the error was on. So it's the errors are fantastic, right? I'm going to get errors for routes, for Java, for Scala templates, for CoffeeScript, for JavaScript, for less, like all that stuff. I'm going to see errors for. It's pretty cool. Okay, let's go fix that. Okay, any other questions before we go on? Yeah, one more.
You were just showing that in the main file you can do the add routes. Would you be able to do that in the CoffeeScript too? So you like have multiple compilers like CoffeeScript and then whatever the compiler is for checking the route, automatically putting the path in there, or then you coding it yourself?
I'm not sure what you mean. Sorry.
So here you have get and then list bars and quotes.
Right. Okay.
Swap that out with actual.
Got it. Yeah. Good question. So, so Play does have a way to take my routing table and insert it into my page. There's some way that in here, I don't remember the exact syntax, but there's some way in this page where I can say, take the routing table, shove it into JavaScript variables so that I can reference those variables in my code rather than putting in string URLs. So that would be the right way to do that. If you look through their example code, they use that instead of the shortcut way that I'm using here. It's a good question. Okay, one more question, we'll move on.
Are there ways that you can have the CoffeeScript extend other CoffeeScripts so that you could just do one min and you don't have to have like 7 JS?
Yeah, so as far as I know right now, they don't do the, what's the right word for that? The concatenation of the JavaScript files. That's something that I hope that they will do in the future, but for right now, I'm pretty sure that it's just all individual files. I could be wrong about that, but does anybody know different? Okay. I haven't seen anyone doing that yet. So I think, yeah, it would be awesome if they did the auto concatenation stuff as well. Okay, let's move on real quick. So I want to show you the Scala version of this example. So the code is going to be very similar for the for the Scala version, except for the controllers are now written in Scala. So let's take a look at the controller. So as I mentioned before, I now have to explicitly map my request parameters. So that's that bar form up there. I explicitly do the mapping. And then you'll see very similar to like what we had before. We have an index method that renders a template. I'm passing in my form object to that because in this case, I'm using the actual Scala helper code to generate my form. Sorry, I'll make that bigger. So this is some of the Scala code I can use to generate my form. You'll see that I'm using the more type-safe way to set up the request parameter there. That's through the Scala routing table, not through the JavaScript routing table. But there we go. So real quick back here. So what I'm doing in the add bar method, this is actually not the right way to do it. Josh Surratt, who's doing a great presentation later today on effective Scala, he told me that this kills kittens, so I should not do folds. There's a better way to do it. I have a new version of this that does it the right way. The right way is to get the value and then map the value and do a get or else on that, because this returns an option. So anyways, I can get errors and then I return bad request. Or if I got the right thing, then I can create my bar. For persistence here, I'm using anorm. Anorm stands for, anorm is not an ORM. So with anorm, you have to do a lot more legwork to do your persistence. There's been a lot of debate in the Play 2 community about should anorm be the default instead of something that is ORM. They've chosen anorm. It's not an ORM. So you don't get all the fancy ORM features, meaning this SQL file for this, I had to actually write this myself. Not a real hard SQL file, but I had to write that myself because anorm is not an ORM. It's not doing this stuff for me. Also, if we look in here, you'll see that I'm doing mappings. I have to map like I'm doing a select. I have to tell anorm how I map from the result rows essentially on this select, how I map those into my bar case class. So anorm, it's not an ORM. They have a great manifesto for why ORMs suck on the Play 2 website in their documentation for anorm. So it's a manifesto. The great thing is, if you want to use an ORM with Scala and Play 2, you can. There's a ORM Scala framework called Squirrel that works really well with Play 2. It's easy to plug in. So if you don't like ORMs, anorm's awesome. If you do like ORMs, check out Squirrel instead. Yeah, question?
Can you externalize the mappings a la MyBatis in this?
Not that I'm aware of. Yeah, not that I'm aware of. So let's see, what else in here? So and then the JSON functionality, very similar as what we saw before. So most of this is pretty similar with the exception of the anorm stuff. So all this code that I've been showing you is all on GitHub. So github.com/JamesWard. And then there's play2bars-java and play2bars-scala. So if you want to go through this code later, just go there and check it out. OK, so real quick, I'm going to take a couple minutes to show one of my other favorite features of Play 2 is how we deploy this on the cloud with Heroku. So to do the deployment on Heroku, I need to do two setup steps. Heroku provides a Postgres database just out of the box for every application. There's lots of other options available, but the default is Postgres. So I need to configure my application to use Postgres instead of using the in-memory H2 database. And the way that I'm doing that is I'm specifying some configuration options, which you can't probably see very well. You'll see those in a second better. But in this proc file, the proc file is what how Heroku knows what process to start on the system. So for Play Framework, we call target/start, and we give it the HTTP port, and then we're telling it to just auto-run the evolutions. We're specifying to use the Postgres driver and use the database URL environment variable. And then we just follow these steps. So let's just do that real quick so you can get an idea for how that looks. Oop, and I got to switch back to foobar. So the first thing I have to do is add in that Postgres driver dependency. So let's go back here to my project build.scala. So this is where I specify my dependencies for SBT. So my dependency is going to be PostgreSQL. That's the group name. PostgreSQL is the artifact name. And then the version is 9.0-801.jdbc3. Okay, so we'll save that. So that's going to get the right driver. Now I do need that proc file. Instead of writing that out by hand, let me just go copy that from somewhere else. So I'll take it from my play2bars Java proc file. So let me copy that in here. Let me show you that real quick so you can see exactly what's going on here. So this is my proc file. So this just tells Heroku what process to run on the system, and then because I'm changing the database configuration, in the type-safe configuration system, you can pass in the configuration parameters either on the command line, or I could have alternatively set up a different configuration file. There's like 4 different ways now to do configuration in the typeface config system. The easiest one in this case is just to specify those as options on the command. So that's how it's going to know what data to connect to that Postgres database. Okay. So that's it. So to deploy this on Heroku, I'm going to do a git init. We use git as the transport for uploading the application up to Heroku. And then I'm going to add all my files and commit them. And then, so there we go. There's all my files. I didn't really need to commit my idea files. Oh well. So now I'm going to call Heroku, and I'm going to say create an application for me on the Cedar stack. Cedar's the 3rd generation of Heroku that supports Java, Scala, Play Framework, Node.js, Python, all sorts of new exciting stuff. So hopefully if my 4G works, we'll get a new application created on Heroku, and then we'll deploy it. There we go. So I get automatically assigned for me an HTTP URL. I got warm light 4200, and then I also get a git URL, which is where I'll push my application to. So now I can just do git push Heroku master. This will take my Git repository. I can put whatever I want in there. I've chosen to put my source code in there in this case. It'll upload that up to Heroku. Heroku will now, in this case, run the SBT, the Scala build tool, build on this project to build it. And then once it's built, it'll deploy it onto what we call a dyno. Dynos are essentially 1 free dyno per application per month. So you can, as developers, get started and use it for free. It's only when you scale beyond that 1 dyno that you have to pay anything. It's like 5 cents per dyno hour. So this will deploy it on 1 dyno and then start up the process that's defined in the proc file. So it'll look in this proc file and say, all right, I'm going to call target/start, and then Play Framework will come up. Okay, so the SBT build, that's going to take a minute to run. It's downloading dependencies. You'll see that my upload was very fast because I didn't have any of my dependencies in my Git repository. But now, as it's running the SBT build, it's having to pull down all the dependencies. So that'll take a second. So while that's running, let's go on to the next part, which will just take a minute and see how we're doing in time. Okay, we'll wrap up in like 4 minutes so that we can stagger the lunch. Okay, so the next thing I want to talk about is, all right, I've shown a little bit about how we can start to embrace this like new modern architecture, client-server architecture. We can move the client side of our application actually out to the client side. We can make it all static assets. That's great, but kind of the next step of this is to deploy it on a CDN, deploy the whole client side of our application on a CDN. So the traditional model with an application is I've got my app and all the static content for the app. I've got all that on one system essentially. You know, it could be multiple servers, whatever. And this is probably most likely centrally located unless we're, you know, Facebook or Twitter and can do like geo-distributed data and stuff. So this is most likely in one geographic place, one geographic region. So let's say it's on the East Coast. Our requests to this application from the East Coast are going to be pretty fast. But our requests to this application from the West Coast or from Asia, they're going to be slower. Obviously, it has further distance to travel. Speed of light doesn't get any faster, unfortunately. Well, maybe it does. I guess there's been some new findings about that, right? So what we're trying to do now in this new architecture is make it so that the number of requests that we're making back to that central location is much smaller in number, but also much smaller in size, because we're just doing the requests for data in the application back to the central place. So those are our JSON services, those are our RESTful services. But then we've taken the bulk of our application, the whole client side, all the HTML, JavaScript, CSS, images, all that static content, and we've moved it onto a CDN and edge cached it. What that means is we've taken copies of it. We've put a copy on the East Coast. We put a copy on the West Coast. We put a copy in Singapore. We put a copy in London. So we put copies of the static content all over the place. And so no matter where somebody hits the app from, it's going to be much lower latency for those requests for the bulk of the application. And it's only the requests that are going back to get actual data that are going to potentially be longer. Geo-distributing data is a very hard problem, so that's why we try to avoid that. Okay, so I have a little example app that I want to show you real quick that does this. So I started working on a little way to to be able to take templates of applications and be able to fork those on Heroku. So this is my little application I built in this modern style of web applications where the application is, what's running on Heroku is just the JSON services essentially. And then I've taken all the static content and moved it onto CDN, onto a CDN, onto the CloudFront CDN. So when I load this page, let's do that again so you can see it. When I load this page, I get my first request, which over 4G, it's taking 800 milliseconds or so. But then you'll see that request, all that it is just a little bootstrap to bootstrap the application. Then I make a bunch of requests out to the CDN, and you'll see that all of these requests actually are happening in parallel. So that's a little annoying. In a modern browser, we can do a bunch of requests at once. We could also use CNAMEs to do this. But you'll see that these requests are very, very fast compared to the other ones, right? Because this content is possibly like right down the street from me, right? It's much closer to me than my application potentially is. And then once we load all the content, the whole client side of the application, you'll see I'm loading Bootstrap and jQuery and my index.js, which came from, of course, CoffeeScript. And then here I make a request for data. I need to get this list of tags. That's data. So I make a JSON request back to my Heroku app, and that's only 736 bytes and only took 116 milliseconds. So, and then I also do the same thing to get the list of apps there. So when I get that data, I then render it using jQuery the same way that you saw me do in the example. And then, of course, this is a single page application essentially where if I want to get details for one of these, that didn't refresh the page. You'll see that it did change the URL. I'm using the HTML5 history API to change the URL, but I didn't refresh the page. The only request that made when I clicked that was to a little JSON request that was 903 bytes to get the details for that particular one. So anyways, just wanted to show you that to give you an idea for what this actually looks like in practice, to move the client side out to a CDN, to just talk JSON back to the server, that sort of thing. All right, let's check and see. Oh no, my app failed. Oh, I must have spelled something wrong. Not fun. Okay, I spelled my JDBC driver name wrong. Postgres. I forgot a G. Oh, somebody should have caught that. Okay. Well, I'll try again, but we're gonna wrap up before probably the SBT build finishes. Let's go back to my build. Postgres. Pair programming failure. Okay. Git commit -am. Whoops. Git push Heroku master. Okay, I think it's going to have to rerun the whole SBT build. But while that runs, let's see what else here real quick. I didn't have time to go into the async and WebSocket stuff. There's some really great examples of how to do this in Play 2. If you download Play 2, let me show you real quick. If you go into Play 2 and then samples, there's a bunch of samples for both Java and Scala that show you how to do Akka for async, how to do WebSockets with Akka. Some really great examples in there. So let me show you the Java one. So there's a Comet Clock one. There's a WebSocket chat one for Java. And then for Scala, there's also the same sorts of examples. So if you want to see how to do the real-time async stuff, just check out their samples. They're really great. Okay, let's see what else. Okay, I think we're just about out of time. We'll head over to lunch. Any last questions about anything? Okay, everybody's ready for lunch? Let's check the build. Let's check the build real quick. Oh, it's almost done. Give me 30 seconds. Compiling Scala. So we will be running this on the cloud. But we'll wrap up. I'll be around for other questions, but hopefully that was useful. Thanks for coming. Enjoy lunch. Thanks.